The second distribution that we will work with in this course is the normal distribution. This is one of the most common distributions. You all might have encountered that in a variety of settings before. It has just widespread applications. Neat feature about a normal distribution is that it is completely defined by its two parameters, the mean, which is measured by mu, and the standard deviation, which is sigma. The density function for normal distribution looks like this intimidating, scary formula, but it is, we will not really work with this formula directly. We'll work with what we call a standard normal distribution, which I'll introduce in just a little bit. But the density function is given by 1 over sigma root 2 pi e to the power negative 1/2 x minus the mu, which is the mean divided by standard deviation, the whole squared, where pi is the usual 3.1415, and then e is the Euler, the natural number, 2.718. Now, this is an example of a normally distributed random variable x with mean 100 and standard deviation 25. So we see that this is symmetrical. This distribution has several nice properties. The mean gives us the highest point. So if I kind of draw a line down, this will be 100. It is also the same as the median and the mode because the distribution is symmetric around the mean. Then the area to the left of the mean consists of 50% of the area under the curve. Then area to the right is also 50% of the area under the curve. So it is a symmetric distribution. In terms of the impact of changing the mean and the standard deviation on this shape, mean for the same standard deviation will just shift the distribution to the right. If the mean increases, you would expect the distribution to be like this with the same spread. And then if the mean decreases, the distribution will shift to the left with the same spread. For the same mean, if standard deviation increases, the distribution will become wider. If standard deviation decreases, the distribution will become narrower. So again, the change in the parameters will either shift the mass of the distribution or will shift or change the spread of the distribution. Now, as we mentioned before, we will not really work with the normal distribution. What we will work with is a special case of the normal distribution called the standard normal distribution. Standard normal distribution has a property that the mean is 0 and the variance of standard deviation is 1. Again, this gives us the probability density function for the standard normal distribution, where notice that instead of x, we now have the z, x, but with a mean 0 and variance 1. And then the standard deviation here also went away. So this is a simplified version, and this is the version that we will work with throughout this course and in all the applications we will do using the normal distribution. What is the advantage of standardizing or converting the normal distribution into its standardized version? We can use tables or software to calculate a variety of cumulative probabilities. Cumulative probabilities are probabilities up to that point. So probability that the variable takes a value less than or equal to the given value. So let's say that our z is over here. The area to the left will give us the probability that our normal variable z takes a value less than or equal to that. To find the value in the interval, and the cumulative distribution will give us probability to the left. So we find the value to the left of a given value of z, and then value to the left. The intermediate area will be the value, probability that the variable will lie in between any two z values. Again, to the right, we can do the same thing. Will be a right tail, or we can look at the value up to this point and then subtract it from 1 to get the value to the right. And this is what we will work with in JUMP to obtain the normal distribution. We can kind of do the same thing. We go to help, we go to sample index, and then we go back to our distribution calculator. And it opens up with mean 0 and standard deviation 1. So if I wanted to find the probability that the value lies, let's say, between minus 1.5 and plus 1.5, you can say input the values and calculate the probability. So I'll choose minus 1.5 and plus 1.5. And we get the probability that our value z lies between minus and positive 1.5 would be 0.866. So this is how we will use the distribution calculator to work on problems involving the standard normal distribution. What is neat is that we can convert any random variable x which follows a normal distribution to a standard normal distribution. The process is called standardizing the variable. All we simply do is we just subtract the mean and divide the difference from the standard deviation. So this is often called centering when we are dividing or subtracting a given value from the random variable x, and the process of dividing it by the same value is called scaling. So this is centered and scaled. So for example, if you want to find the probability that a random variable which follows a normal distribution with mean 100 and standard deviation 20, what is the probability that this variable will lie between 100 to 140? We can now transform 100 to its z-score, and we can transform 140 to its z-score. So we can standardize them. Essentially, we are subtracting the mean from 100 divided by the standard deviation. Mean is 100. And standard deviation is 20. We do the same for 140. So once we do that, we get the probability that z is between 0 and 2. And again, we can either calculate the probability that it's less than 2 and then it's less than 0, or we can now use our jump calculator to find these values. So our left-hand value is 0. And our right-hand value is 2. So the probability that our variable x takes a value between 100 to 140 is same as the standardized version of it taking the value between 2 and 0, which in our case is given by 0.477. So again, standardizing any normal variable to the z-score helps us easily calculate these values.